Hi students, my name is Ratnaprabha Patil. Today we are starting with your new lesson from 11th physics, that is thermal properties of matter. In this lesson we will learn about properties of matter and various phenomena that are related to heat. Phenomenon or properties just like temperature changes and heat exchange. These are termed as thermal phenomena or thermal properties. Just like that, you have heard or you have seen these examples in maybe in geography in or in science, just like which is given in your book also, that why the direction of wind near a seashore changes during day and night, why the metal lid of the glass bottle comes out easily on heating, and why two metal vessels locked together can be separated by providing heat to the outer vessel. These examples you have studied or you have heard in your earlier standards, right? Means how heat exchange takes place in, just like you can say, in solid, liquid or gases. Along with that, when temperature of solid, liquid and gases increases or decreases, what will happen with its volume, or you can say what will happen with the dimension of solid, liquid and gases. These properties we are going to study in this lesson. Okay. So, first point is the thermal expansion. That is, you are knowing this, when matter is heated, normally it expands, and when cooled, it normally contracts. Just like you can say the example of water, that if ice or water is, you can say, heated, then or ice is heated, it expands, converted into the liquid, and liquid contracts when water is converting into the ice. Okay, atoms in solid vibrate about their mean position. When heated, it vibrate faster and force each other to move a little further apart, and this result into expansion. As you are knowing that solid is a having perfect size and shape, it is because its arrangement of molecules or molecular arrangement is fixed. But if you provide heat or temperature to the solid, the molecules of solid will vibrate about their mean position. Just like you can say sewing machine. A sewing machine is having one fixed position. It is, you can say, it is restricted to move in up and down direction. Okay, and it's, that is what it, the sewing machine or sewing machines is, that needle is moving up and down about its mean position. Just like that, molecules in solid also vibrate when you change the temperature, or if you provide the heat to the solid, it will increase the temperature of solid, and result of that, molecules in the solid will vibrate about their mean position, maybe up and down and to and fro motion. Okay, when temperature is more, molecules vibrate faster, and if they vibrate faster, they force each other to move little further apart, and as a result there is a expansion in solid. The molecules of liquid or gas move faster and force each other to move little further apart, and this is the result of an expansion of liquids and gases on heating. The expansion is more in liquids than solid, and gases expands even more. It is because molecules of liquid and gases are somewhat free than solid. Solid molecules of solid are restricted, right? Means they are solids having perfect shape. It is because molecules of solid are having their mean or fixed position. By providing heat or energy, we can change its position, but they will move about their mean position. But for in liquid and gases, there is a molecular distance between molecules of liquid is less, or sorry, force of attraction between the molecules of liquid is less as compared to solid, and in gases it is too much less, and hence solid expansion of solid is too much less as compared to liquids and gases, and gases expands very much if you are providing a heat to the gases as compared to solid and liquid. A change in temperature of a body causes change in its dimension. The increase in the dimension of body due to increase in its temperature is called thermal expansion, which I have told you already that if temperature changes, body causes the change in its dimension. The increase in the dimension of body due to increase in temperature is called as thermal expansion. There are three types of expansions: linear expansion, areal expansion, and volume expansion, which we are going to study in next part. You can see that is, this is linear expansion. Linear expansion is what? The expansion in length due to thermal energy, or you can say due to change in temperature of body. Expansion of length takes place. This is called as linear expansion. As you can see here in figure, that L is the length of the rod, and after applying temperature you can say there is a change in the length of the rod, that is delta L. There is an increment because you can consider here we have increased the temperature of rod. You can see L is the length of the substance in the form of rod. Here we are studying linear expansion, that is why we are going to take a rod which is having length L. Then what is delta T? A small change in temperature, means T is the temperature at which rod is having length L, and if you increase the temperature little bit, then delta T is a change in the temperature. Okay. Then the fractional change in the length of rod is directly proportional to change in temperature, which I have mentioned in terms of mathematical form, that is delta L by L, that is fractional change in the length of rod is directly proportional to change in temperature. Change in temperature is what? Delta T. See here, this is what? Delta L by L is directly proportional to delta T. Delta L by L is what? Fractional change in the length of the rod, and delta T is what? Small change in temperature. If you have to remove the directly proportional sign, you can take a constant, that is delta L by L is equal to alpha into delta T. And here Alpha is what? Alpha is called as coefficient of linear expansion of solid. Okay, and alpha is not same for every solid material. It is different. It is because material is different, then coefficient of linear expansion is also different, and value of this will be different for different materials. Okay, now you can write from above equation. From this equation you can write alpha. You can take delta t to your left hand side. You can write alpha is equal to delta L divided by L into delta t. So instead of this you can write delta, instead of delta L you can write, here we can write alpha is equal to delta L divided by L into delta T, right? So instead of delta L and delta T we can write here that is LT minus L0. So L0 is what? L0 is length of the rod at 0 degree Celsius, or you can say at lower temperatures, or you can say initial length of the rod. Okay, and LT is what? Length of the rod when rod is heated to T degree Celsius, or you can say length of or final length of the rod after heating. Okay, then L0 in bracket T minus T0. T is what? Final temperature, and T0 is what? 0 degree Celsius, or you can say initial temperature of the rod. Now delta L is what? LT minus L0. You can see here delta L is what? LT minus L0, which is change in the length of the rod, and delta T is what? Rise in the temperature or change in the temperature. Okay, then alpha, you can write it as a LT minus L0. How you can write this? If you can consider this, in this figure L0 is equal to 1 unit and change in temperature is 1 degree. So if both the terms from this equation will be 1, so alpha is equal to what? LT minus L0, and we can define here coefficient of linear expansion of solid by this equation. Okay, so how will we define it? That increase in length per unit original length at 0 degree Celsius for 1 degree centigrade rise in temperature. Okay, and this is what your definition of coefficient of linear expansion of solid. What is? It is defined as increase in length per unit original length. LT minus L0 is what? Change in length, or you can say increase in length. Okay, per unit original length, that is you have written here. Increase in length is what? LT minus L0. L0 is what? Original length at 0 degrees Celsius, or you can say at lower temperatures for 1 degree centigrade rise in temperature. Okay, and this is what? This is about coefficient of linear expansion. Now if you are considering a solid, then if there is a smaller change in temperature, then there will not be any much change in the dimension of solid. Okay, so instead of considering initial temperature is 0 degrees Celsius, we can consider any temperature, and after that temperature, if we are increasing the temperature up to T or final temperature, then may solid will change or expand to the measurable, you can say, length. So we, in terms of solid, we cannot considering lower temperature or initial temperature as 0 degree Celsius. Okay, so instead of that we can consider any initial temperature, and after that, from that initial temperature, if you change the temperature of solid or rod up to certain temperature, and then we can measure the length of the solid. So your equation of alpha will change. This equation of alpha will change just like this. Alpha is equal to L2 minus L1. So L1 is what? Initial length of the rod. L2 is what? Final length of the rod. L divided by L1, initial length of the rod, in bracket T2 minus T1. T2 is what? Final temperature of rod, you can say, and minus initial temperature of rod. Okay, and unit of alpha will be degrees per degree Celsius, or you can say per Kelvin. Okay, this is all about linear expansion, that is expansion in length of solid due to thermal energy. And alpha is what? Alpha is the coefficient of linear expansion. Now we are going to study areal expansion. Areal expansion is what? When after changing the temperature, there will be the change in area of the solid, or you can say on, that is increase in delta A in the surface area on heating is called as areal expansion or superficial expansion. As you can consider here in image or in figure, you can see that there is a one plate which is having surface area A, that is the blue square, that is the plate which is having surface area A. And after giving the temperature, or after increasing the temperature of the plate, delta A, another circle which is bigger circle, that is change in the area of the plate. Okay, so here A is what? A is the area of substance in the form of plate. Firstly, what we have took? One rod. Here we took the change in the, or expansion, that is expansion of rod. Then rod will expand in terms of, or linearly, right? Here we are considering one plate. So if it will expand area wise, means its area will get increase. Again here delta T is what? Small change in temperature. Again here, that is fractional change in area is directly proportional to delta T, that is change in temperature, just like we have seen in linear expansion. So here delta A divided by A is directly proportional to delta T, and if you want to remove this proportionality sign, we can take constant as a beta, that is delta A divided by A is equal to beta into delta T. So here beta, which is constant, is called as coefficient of areal expansion of solid. Here alpha is what? Alpha is coefficient of linear expansion. Beta is what? Beta is coefficient of areal expansion of solid. So by rearranging the above equation, which is this equation, if you rearrange that, if you took delta T on other side, what you will get? Beta is equal to delta A divided by A into delta T. And instead of delta A and delta T, we can write AT minus A0 divided by A0 in bracket T minus T0. So here A0 is what? Area of plate at 0 degree Celsius. AT is what? Area of plate when it is heated to T degrees Celsius. Now, delta T0 is what? 0 degrees Celsius or initial temperature of plate. T is what? Final temperature of plate. Then delta delta A is what? Change in area. That is delta T, AT minus A0. Next is delta T, which is T minus T0. Again, just like in linear expansion, we can write beta is equal to AT minus A0. How we can write it? Because if you are considering initial area A0 in this equation, initial area A0 is 1 unit square or 1 unit, and change in temperature is 1 degree Celsius or Kelvin. So, beta is what? Beta is equal to AT minus A0. Okay. So, now again we can define coefficient of areal expansion as the increase in the area per unit original area at 0 degrees Celsius for 1 degree rise in temperature. Again here unit of beta is what? Per degree Celsius or per degree Kelvin. Unit of beta is per degree Celsius or per Kelvin. If you are considering solid, then if you are considering initial temperature as 0 degrees Celsius, then and if you increase the temperature of solid, then there will not be any or beta, or you can say coefficient of areal expansion will not increase or will not vary much with the temperature. So instead of A0 you can write A1, and instead of T0 you can write T1. That is, we can consider any temperature other than 0 degrees Celsius as initial temperature. So beta you can write it as A2 minus A1 divided by A1 in bracket T2 minus T1. Now we can see your next point, that is volume expansion. That is, the increase in volume due to heating is called volume expansion, or you can say a cubical expansion. Then if you are considering V is a volume of substance in the form of cube. Here you can consider a solid cube, or you can say a cube consisting of liquid, or you can say gas. That is, volume expansion takes place for liquid and gases also. Okay. Then delta T is what? Again, small change in temperature. So delta V divided by V, that is fractional change in volume, is directly proportional to change in temperature. That is, delta V by V is directly proportional to delta T, which is equal to delta V by V is equal to gamma into delta T. Here constant of proportionality was gamma, and which is called as coefficient of volume expansion of solid. Okay. Next, you can rearrange above equation, that is gamma is equal to delta V divided by V into delta T. Instead of delta V and delta T, you can write Vt minus V0 divided by V0 in bracket T minus T0. So here V0 is what? V0 is volume of cube at 0 degrees Celsius. Vt is what? Volume of cube when heated to T degree Celsius. Then T0 is what? 0 degree Celsius, or you can say initial temperature of that cube. T is what? Final temperature. Then Vt minus V0 is what? Change in volume, not area. Okay. I have written here wrong. This is not area. This is change in volume. And delta T is what? T minus T0, which is rise in the temperature. So, from this equation, you can write this. That is, if initial volume of cube is 1 unit and change in temperature or rise in temperature will be 1 degree Celsius, then you can write gamma is equal to Vt minus V0. And by this way, we can define volume expansion as the coefficient of cubical expansion of a solid is defined as increase in volume per unit original volume at 0 degrees Celsius for 1 degree rise in temperature. Okay, this is what definition of coefficient of cubical expansion. As V1 is initial volume of the body, V2 is final volume of the body, T2 is the final temperature of the body, and T1 is the initial temperature of the body. Then you can write coefficient of cubical expansion, that is gamma is equal to V2 minus V1 divided by V1 in bracket T2 minus T1. So unit of gamma is what? Per degree Celsius or per Kelvin. As I have told you, volume expansion or cubical expansion is for solid as well as liquid and gases. That is, we can put or we can keep fluids just like liquid and gases in the cubical container. And if we increase the temperature of gases and liquid, there will be the expansion of liquids and gases as well. So fluids just like that is gases and liquids also shows volume expansion or cubical expansion. That is, if expansion of fluid results into the volume greater than the volume of cube or container. So what will happen? Fluid will get overflow if container is open, and if container is closed, just like that. This is cube in which we have kept gas or liquid, and we have increased the temperature of that liquid or gas. If container is open, what will happen? That liquid and or you can say gas will expand and come overflow if container is open. And if this container is closed, then what will happen? Then that liquid or gas which is present in this cube will cause additional pressure to the walls of container. Okay, and you can see the example just like that. If you are take the example of balloon. If there is a increment in the volume of gas which is present in the balloon, what will happen? Balloon will get burst. Okay, and this is what one example where there is a expansion of gas takes place, and if container in which the gas is filled or kept, if it is closed, what will happen? That balloon will, just like that, it will get burst. Okay, this is all about expansion. What expansion you have studied? That is thermal expansion, in which linear expansion, aerial expansion and volume expansion. Now we are going to see the relation between coefficients of expansion, in which first relation is beta and alpha. Okay, as we have considered before, L0 is what? Side of, here we are finding out the relation between alpha and beta, or you can say beta and alpha. Then for that is, beta is what? Coefficient of areal expansion, and alpha is what? Coefficient of linear expansion. So here we are going to consider a one solid plate, and that plate is having side, that is square plate having side L0 at 0 degree Celsius. Okay, we can consider there is a one plate which is having side L0. Okay, I cannot write 0 correctly. Okay, yes, L0, right, at 0 degree Celsius. And if you increase the temperature, this side will get some, it will expand, and in expansion what will happen? That side will increase its length, and that is LT. Now you are knowing this from linear expansion. What is that? That you can see here. Here what we have written, alpha is equal to delta, sorry, here delta L divided by L is equal to alpha into delta T, right? So this equation you can rearrange, and what you will get? Delta T, sorry, LT is equal to L0 1 plus alpha T. Okay, so now this plate which we have considered is having area A0 at 0 degrees Celsius. Okay, so how we can calculate the area of square? That is, area of square is equal to its length square. So A0 is equal to what? A0 is equal to L0 square. And AT is what? Area of the plate when there is a change in the temperature or increment in the temperature, that is T0 degree Celsius. So you can write this equation as this, that is AT is equal to LT square is equal to L0 square in bracket 1 plus alpha T square. So this equation came from coefficient of areal expansion. You can see here from this. There is A0 divided by AT is equal to beta into T. And this equation, if you rearrange, you will get this equation. AT is equal to A0 in bracket 1 plus, sorry, not this equation. This equation came from this only. That is AT, instead of LT square, you can write AT. Instead of L0 square, you can write A0 1 plus alpha T square. And this equation came from areal expansion, that is from this equation. Okay, so by rearranging that, you will get AT is equal to A0 in bracket 1 plus beta T. So if RHS of both the equations are same, you can write this equation as A0 1 plus alpha t square is equal to A0 1 plus beta t. So A0 will get cancelled from both the sides. So square of this 1 plus alpha t square will be 1 plus 2 alpha t plus alpha square t square, which is equal to 1 plus beta t. As alpha, that is coefficient of linear expansion, is a small, so its square is again small. So alpha square t square we can neglect, as alpha is very small. So again 1 will get cancelled from this. Alpha square t square we can neglect as alpha is very small. So and t will get cancelled again. So beta is equal to 2 alpha is the relation between alpha and beta, that is coefficient of areal expansion is equal to 2 into coefficient of linear expansion. By this way, you can find out the relation between gamma and alpha. Gamma is what? Coefficient of volume or cubical expansion, and alpha is what? Coefficient of linear expansion. Again we have considered here both the things, that is L0 side of the cube instead of square. Here we have considered cube. Okay, so just like this cube. Okay, this we have considered. Then cube is having side L0 at 0 degree Celsius and LT when its temperature increases to T degree Celsius. So this equation is from your coefficient of linear expansion, that is LT is equal to, or in linear expansion part you can see this equation, or by rearranging one equation you will get this, that is LT is equal to L0 1 plus alpha t. Now V0 is what? Volume of cube at 0 degrees Celsius. V0 is equal to L0 cube, that is volume of cube is equal to what? V is equal to its length cube, and Vt is volume of cube at T degree Celsius. So you can write Vt is equal to Lt cube, which is equal to L0 cube in bracket 1 plus alpha t. So in this equation you can write by this way, that is Vt is equal to V0 in bracket 1 plus alpha t cube, and this equation is from, that is volume expansion or cubical expansion, that is this. By rearranging this equation you can write this. Okay, this equation second, and you can equate these two because Vt is equal to Vt is equal to, so you can equate these two equations. What you will get? V0 in bracket 1 plus alpha t cube, which is equal to V0 in bracket 1 plus gamma t. So V0 get cancelled, and expansion of this bracket will be 1 plus 3 alpha t plus 3 alpha square t square plus alpha cube t cube, and this bracket it as it is. Then 1 will get cancelled from both the sides. Again alpha is very small, so higher powers of alpha can be neglected. So these two terms we can neglect. Okay, so gamma is equal to what? 3 alpha, that is coefficient of cubical expansion is equal to 3 into coefficient of linear expansion, and this is about the relation between alpha, beta and gamma, that is alpha is equal to beta upon 2 is equal to gamma upon 3. Okay, this is all about your first lecture of this lesson, that is thermal properties of matter. Okay, so next part we will see in your next lecture. Okay, so thank you.